How's everyone doing? I'm gonna be doing project 1. So you're gonna start out in the workbench and you're gonna open up Fluent. You're gonna right click geometry and do new design model or geometry. You're gonna wait for that to open up. You're gonna make it normal to the z-axis and zoom in a bit, just so it doesn't blow anything up. You're gonna go ahead and sketch. Make sure units are in millimeters. I want to zoom in. I found 80 millimeters. It's kind of a good area. And once you do that, you're going to go to sketching, just do a rectangle, and kind of just make one, and we'll do the dimensions later on. And so now we'll go to dimensions. We'll do dimensions. I'll do millimeters. And then if I do that 6 millimeters, I'll do the length 50 times 6, which is 300. Oh, not like that. 300 for the length. And so that should be the length of it. Go to modeling. Do go concept, surfaces from sketch. And go ahead and generate it. So back to workbench now. And open up the mesh. And it should open up eventually. There we go. And there it is. Cool. So go back to the z-axis. Go ahead, insert method. And we'll go ahead and insert another mesh. But this time it's sizing. Now we're going to do the edge select. Now control click on the two sides. Hit apply. Number of divisions, and let's just do 100. And then we'll do no, hard behavior, and everything else looks good. So we'll just generate. And we're going to insert sizing, another one. We're going to go ahead and do the top and bottom, hit apply. Same things to number of divisions, and same things to hard. And here we'll do 500. And go ahead and generate. Now we're just going to surface mesh. So let's go ahead and name the sides now. Go ahead, put this, hit N. We'll name this outlet. Will be lower wall. This will be upper wall, and this be inlet. Head back to Workbench now. Go ahead and press update. And now we'll set up for Fluent, double precision. And then I think that's it. We can go ahead and start it now. Some key behavioral changes if you want to read about those. I don't. So gonna go ahead and edit, make sure it's laminar, press OK. Yep. Now we're gonna go ahead with fluid, do air, and then density, we're just gonna do 1, just to make it simpler. And for the Pizzelle viscosity, let me see what I used really quick. So for viscosity, I did 1 to the E. 1 to the E minus 5, I believe, yes. Minus 05. All right, there we go. I need to close it for some reason. It doesn't just auto close. And now let's go to the boundary conditions. So we're gonna go velocity inlet. We're gonna do 8 meters per second. I believe that's what I used. Yes, 8 meters per second. And go ahead and hit apply. And then close. Everything else can stay the same. Everything else looks good. Just make sure the wall is stationary. Okay, cool. Cool. And I like to stay as pressure. You really just need to make sure that inlet is velocity and make sure you have velocity that works. I'm using 8 meters per second. When we go to the reference values, and we can compute from the inlet. And then we're going to now initialize and calculate. We're just going to have it run for a bit. Oh, wait. Iterations. I'll do 200. Just so it can be a bit better. You can see it a bit better. All right, let's run it again. And as you can see, there's a continuity x velocity and the y velocity. I was just kind of running through it all. All right, calculation complete. Now we'll go ahead and go to results, vectors. And we go ahead and display them. There we go. And as you see, the Pizzelle flow is kind of pushing in towards the center. And then we go back to workbench. And I'll update the results. And now let's open up results. And like everything else with Fluent, it's gonna take a bit. Cool. We can get rid of the meshing. Done with that. And design modeler, just to hopefully run a bit faster. Cool. Zoom a bit more. Now we're gonna do contour map. We're gonna do symmetry. Make sure it's velocity U. I think all of this is fine for now. Just to make it a little less grainy, we'll increase the contours. I think 100 is what I used for the project. Okay. We'll do horizontal. Then I'm just kind of making it a bit better looking, just so you can save. Now we're gonna do a line. Let's call this midpoint for when we do the velocity profile. So for this, it'll be halfway. So I did 300 millimeters. So 0.150. 0.150 would be meters and 150 millimeters. And this will be the height 0.006 because it's 6 millimeters up. Do 100 samples and go ahead and generate that. If you see it, it's in the middle of the pipe. And then we're going to go ahead, insert. I'm just going to insert another line. We'll call this one endpoint. I can spell. All right, cool. And then this one will be a little bit to the end of, not exactly at the end of the pipe, just a little bit, just to make sure that we have everything. So I'll do 290 or 295. We'll do 299 along the edge. No, I'm not that brave. 200, and again, the height will be the same, 0.06, apply, not that way. 295. go ahead and check it. And yep, just towards the end, not exactly at the end. We'll do 9.7. Let's get it a little more towards the end. That looks a bit better. Now we'll make the velocity profile. So we're gonna go to chart. We'll call this velocity profile. And the title we'll call velocity. Then we go to data series. Series 1 will be at the midpoint, and we can call it midpoint. Apply that. Make another, call this one endpoint, and then endpoint. X-axis, we're going to do velocity u. Y-axis, we'll do height, which is just y. Let's just apply it. All right, cool. Now you see the Poisson flow. You see it starts at 0, and then midpoint is getting into that kind of parabolic shape, and then the endpoint is going all the way. And then now you can screenshot this, and you can screenshot where is it? This as well for the project, and you just go back to, not to that. Here we go. Go back to the Fluent, and now we're going to go ahead and go back to boundary conditions. We're just going to make this, this is for the co-op flow. You can just make this a pressure inlet. Just make sure there's no velocity. Make sure it's all 0. Going to hit apply and close. And then you can make any wall move. I make the upper wall move. I think I used, let me see. I did 0.1 meters a second. I found is was good for the velocity profile. Everything else looks good. Go ahead and close that. And then see, I think you just you run it from here. Let it do its thing. It's almost there. All right, and now if we go back to post, you can just press yes, and it's going to refresh everything. Hopefully I did it correct again. Let's go to the chart viewer, apply. 1 second. Oh, I forgot to change the viscosity. Viscosity for the co-op flow, I used 1 to the e minus 2. Go ahead and change and create, close, and now I think we're good. Let's just go ahead and initialize and calculate. Calculation's complete. Now let's go back and let's check now. This is looking more familiar. Yep, there we go. As you can see, it has that linear profile for the velocity, and they're on top of each other. You can't see it, but if we, for instance, get rid of the endpoint and apply, you see they're the exact same line, which makes sense because there's no change in velocity. For the co flow, it just stays in that linear pattern, and the 0.1 meters per second is moving at up here where the wall is, 0 here with the no slip condition, and then making that velocity profile. Now for the co flow, I put the viscosity back to the original one, but 1 to the e -5. I found that just worked better for the combined. And then I went to the boundary conditions, had the inlet back to velocity inlets, 8 meters a second. Make sure you apply it. And then the upper wall, I also changed the speed to 8 meters a second to stay in line with the inlet velocity. So apply, close, just make sure velocity, make sure that's 8. Cool. And so I believe that's all you have to change. Initialize and calculate. And making all the graphs. Cool. All right. Calculation complete. Go back to post. Update the data. And let's see if it, yeah. All right, cool. So if we go back to 3D viewer, we have the combined flow here as well. Apply just to make sure. Yeah. And so now you can screenshot these as you needed to, and as you can see, it's a combined flow as like the moving plate up here. That's why the velocity is at 8. That's the poisal shape, the parabolic shape that it does, just a little off-centered. And so that's all you need for the velocity profile and Fluent itself. You can just screenshot these and add them. If you wanted to, you can get an Excel sheet with the data tables, and for that, it will allow you to sift through them and find the midpoint. You can also kind of eyeball it with the graph because it has the heights. And so you can go ahead and do file, export, export, make sure location is inlet. You can name it whatever you want. And then generic, boundary data, and location, inlet, and then go ahead and go down to, where is it? Velocity U. And then you go ahead and press save, and it'll export it, and you can open up the CSV as an Excel file, and it'll show you all the data. But I already did the project, so I'm not going to save anything else that I don't need. But yeah, that's everything that you need to do for this project. Just get the contours, get the velocity profile, and then if you want, you can zoom in and kind of see how it gets pushed up with the combined flow. But yeah, that's everything you're going to need for Fluent for this part, and then you just make the report from there. So yeah.